Welcome to CD-LACOM video series number 4, Volume Calibration with Imaging Modalities. In this video, we will review calibrating the volume signal using an end-diastolic and end-systolic volume derived from an imaging modality. This method is best suited for applications where one seeks to monitor relative hemodynamic changes from an arbitrary baseline, as the accuracy of the volume calibration is directly related to the quality of the imaging modality. That said, the relative or percent change from this arbitrary baseline is extremely accurate due to the high-fidelity signals provided by the PV loop catheter. Volume calibrations can be performed during a case in real time in live data mode once at least one PV loop recording has been captured. Recall in video number 1 of this series that we can input ventricular end-diastolic and end-systolic volumes when creating a new study if those volumes are known before study setup. If they were inputted, a volume calibration prompt will appear after recording and saving your first recording. If this first recording is your baseline file, select Yes. If this first recording is not your baseline file, select No. This volume calibration prompt will reappear after collecting and saving every subsequent recording until the volume calibration is applied or you checkmark Do Not Ask Me Again for this study and select No. Once Yes is selected within this volume calibration prompt, you will automatically enter BiV Conduct NT's volume calibration mode. Within volume calibration mode, we will see the data set this baseline file was saved in, our baseline file listed, and the imaging values input during study setup. Simply checkmark the baseline file and select Apply. After selecting Apply, users will receive confirmation that the volume calibration was successful. If ventricular end-diastolic and end-systolic volumes were not inputted when creating a new study, a volume calibration prompt will not appear after collecting and saving your first recording. Instead, one can manually enter the volume calibration mode and input the volumetric values after acquiring the baseline recording. When first entering volume calibration mode in this manner, we will see dataset 1 and data files by default. Since the baseline file was saved according to these selections, we see it listed here. Next, I will checkmark the baseline file, input the imaging values as follows, and select Apply. After selecting Apply, users will receive confirmation that the volume calibration was successful. Now, return to live data mode to continue data acquisition. Once in live data mode, rescale using F9 or the rescale button in the toolbar. Upon rescaling, you'll notice we can now visualize the volume signal, which has turned from red to blue by default. Similarly, the PV loop has turned from red to blue, and the hemodynamic parameters have turned from red to white. These color changes indicate that the volume signal is calibrated. Note that we only need to apply the imaging values to one data file once. All additional data files collected within dataset 1 will be updated automatically. If the PV loop catheter is removed and redelivered into the ventricle for post-intervention monitoring, like in the TAVR procedure example, those recordings collected during post-TAVR deployment should be saved in dataset 2 and will require a new volume calibration using imaging values measured post-TAVR deployment.